Hey guys, section 8.1 notes. We're going to talk about square root functions and their graphs. So if you take a peek at this first graph here on the left, hopefully you'll recognize the parabola or U-shaped graph in red that we are accustomed to having done. Very recently, we talked about inverse graphs. And if you remember, an inverse graph would be reflected, or the symmetry would occur over this 45-degree dashed line. And hopefully you can see the symmetry there. But what we did with the equations was to do this. If you started off with the original equation of the parabola that we're used to seeing in a quadratic equation, you would flip the x and the y, and then get y by itself. Well, how do we get y by itself? I want to get rid of that squared, I would square root, and then we would end up with this guy down here. But notice the plus minus symbol. So typically we take a square root right at the plus minus symbol. So that's what gets this U-shaped graph on its side right there. Now, however, for our purposes, typically they don't talk about the plus minus symbol. So when we graph a square root graph, take a look over here on the right, it's just going to look like this without the plus minus symbol. And if you think about it, if it doesn't have the plus minus symbol, then that's understood to be positive right there. And if you're talking about the positive portion of the graph, then it would be the top half of it. So essentially that half an arc right there is what a square root graph or square root function looks like consistently. So the question is, what happens to it as far as stretching, shrinking, up, down, left, and right? So let's take a look at a couple examples. So number one, if we're going to be making an arc that essentially looks like this every time, well, that guy's still understood to be a vertex because he's the end point, so to speak. And the good news is we're going to do a vertex exactly like we would have before. So all those other symbols we did, inside the parentheses, inside the absolute value, inside any symbol, we would always switch the sign. So the first coordinate for the vertex is going to be positive 3. And since there's nothing on the end of this problem, understood to be a 0, and our vertex is 3, 0. So real simply, that's where we start. And then it's just a matter of doing this, and we've done this numerous times with numerous graphs, and this is always a possibility to use an XY chart. So I always like repeating the vertex. You don't have to do that, but it kind of reminds me that then I want to work my way up from there. So I want to go with 4. The reason I'm not going to go left, and I'll show you, let's just say that we had tried positive 2 instead. Well, if I plug a 2 in right there for x, 2 minus 3 is negative 1, and then we're talking about the square root of a negative number, which is imaginary, and imaginary does not appear on an xy axis. So that's why this arc always goes off to the right. So that's why I'm trying positive 4. So let's pretend that we plug a 4 in right there for x. 4 minus 3 is 1. Square root of 1 is 1. So I get a second point I can graph. Now, what I'd like to see you guys do is come up with at least 3 sets of coordinates that come out even. In other words, no decimal. So let me go ahead and illustrate what will happen here. If I just go ahead and move up to 5 like we normally would. Well, if I plug a 5 in here for x, I got 5 minus 3. 5 minus 3 is 2. The square root of 2 is roughly 1.4. Okay, but that's an approximation. So, fine, I could graph that. 5 comma 1.4 is right about there. But basically what we need to do is we just need to keep moving up until we find one that comes out even. So if I plug a 6 in, 6 minus 3, plug right here is 3. Square root of 3 doesn't come out even, so I'm not going to use that one. So I'll just work my way up to 7. Plug a 7 in right here. 7 minus 3 is 4. Hey, the square root of 4 comes out even, and it's 2. So really all you have to do is just skip until you find yourself one that comes out even. So 3, 4, 5, 6, 7, comma 2 right about there. And so hopefully you can see that arc that we're talking about here from those first couple drawings. And that's it. It's all she wrote. Okay, now domain and range, it does mention it down below in the notes here. So rather than me wait until the end and skipping back up to this drawing, I'm going to go ahead and do it. So domain and range, simple as this. Keep in mind, domain is the x's, and the x-axis goes which direction? It goes horizontally or left to right. So think in terms of left to right. Bracket, where does the graph start? Well, it starts at an x-coordinate of 3. And where does it go to the right? It goes to the right forever. So I'm going to write positive infinity. And remember, infinities always get the parenthesis. So the range is the y-coordinates. The y-axis goes up and down. So just think in terms of how far up and how far down does this graph go. Well, where's the bottom? The bottom y-coordinate is 0. And same deal, it goes up forever. So we get a positive infinity. All right, number 2. Hopefully you remember we have a little trick for vertices. If you have two numbers inside the absolute value or inside of the parentheses or inside of whatever symbol, so we make a fraction out of it. And we said, okay, 10 over 2. And again, this guy has nothing on the end, so comma 0. Well, 10 over 2 is 5. So I'm going to go ahead and just reduce it over here in my chart. So I get 5 comma 0 for this guy. 1, 2, 3, 4, 5 comma 0. And same deal. I'm just going to plug numbers in. So if I plug a 6 in, that's going to be 22. Square root of 22 doesn't come out even. I plug a 7 in, square root of 24 doesn't come out even. I plug an 8 in, so et cetera, et cetera. So you just have to keep going until you find one that comes out even. So I think, let's see, I'm trying to think this one through. Oh, I know what's wrong with this. I screwed up a sign. So guys, are we not supposed to switch signs when we do that? And I forgot to do it. Okay, so negative 5, 0. That would make some more sense. Now it's going to fit on my graph. Let's try that again. Okay, negative 5, 0. 1, 2, 3, 4, 5. All right, so if I plug negative 4 in, that would be a 2. Square root of 2 does not come out even. If I plug in negative 3, now again, we're plugging it right here for x. So 2 times negative 3 is negative 6. Negative 6 plus 10 is 4. Square root of 4 is 2. And you are more than welcome to use the calculator to do that. But again, here's that arc that we're starting off to the right with. So again, all you have to do is just keep picking numbers until you find one that comes out even. Let's see here. How about positive 3? So put a 3 in for x right here. 2 times 3 is 6. 6 plus 10 is 16. Square root of 16 is 4. Yay, I found another one. Okay, and then we'll hold true to my statement, which is I'll let you come up with one decimal. So let's see. I'm going to go with 9. And if I plug a 9 in, I get 2 times 9 is 18. 18 plus 10 is 28. Square root of 28 is 5 point something. I'm not even sure what that is. You can check it on the calculator if you wanted to. So 4, 5, 6, 7, 8. Oops, I was trying to catch the end of the graph here. So it would be 9, comma 5 point something, which would be right about there. All right, so I really should have tried 8 so it would have fit on my graph, but I think you get the idea. And again, there's that arc that goes off to the right. So domain and range real quick. Domain, and really, guys, all you're doing is basing the domain off the vertex that you had. So I started graphing at negative 5, and I worked my way to the right forever. The range, so I would like to think these are pretty simple. I started at a y-coordinate of 0, and again, I worked my way up forever, so positive infinity. That's your domain and range for those. Okay, real quick, I'm just going to emphasize the domain and range thing. So I'm going to save these inequalities, number 3 and number 4, for video part 2. So feel free to watch that. I'm just going to drop down here and make sure. So here's a pair of graphs that are already on here. So really all we got to do is concentrate on that point right there. If that guy is negative 4 comma 0, then really I already know that I'm using negative 4 right here. And I'm using 0 right here. So the question is determining what's it do as far as the infinity. Well, this one goes to the right forever. And this one goes up forever. So kind of a no-brainer. So a little bit different over here on the right, though. So this coordinate here is 2, comma 4. Now, I know I'm using a 2 and I know I'm using a 4. But you got to think a little bit about it. From left to right, starts at 2, does go to the right forever. Now, I understand it goes down, but we're thinking in terms of left to right now. So for the range, so this is where you got to be a little bit careful. The range actually goes, I'm going to have to write this off to the left. So I want to start with the bottom first. The bottom of the range is down forever, negative infinity. And where does it top out at? It tops out at a coordinate of 4. So there you go. All right, check out part 2 video. Thanks.